This video is going to cover quadrilaterals and classifying each quadrilateral, as well as finding missing values using both scale and scale factor. So let's go ahead and get started. This first slide here shows how to classify different quadrilaterals based on certain criteria. So we created a map just like this in class. It specifically says what each shape has to have in order to be considered that specific type of quadrilateral. So we can use that later on if you need to go back to that slide to solve future slides. That's great, but let's go ahead and keep going. So our first slide says to classify the quadrilateral. So here we see that each side has one of these tick marks, which means they are all congruent to one another. And if we were to look at our quadrilateral classification map, we'd see that this would be considered a rhombus. So this is a quadrilateral as well as a parallelogram, but to be more specific, a parallelogram that has all four congruent sides is considered a rhombus. Our next slide here, our shape has two sets of congruent sides, but their opposite sides are not congruent. So with this specific picture, this is a kite. Again, looking back at that classification map, that would help us decide that this was a kite. Our next two slides are going to be actually finding a missing angle measure. So we talked about how every quadrilateral has a sum of 360 degrees because it is made up of two triangles, and each triangle has a sum of 180 degrees. So here we're given three of our angle measures along with this x degrees. So we're going to set up an equation, 135 plus 135 plus 45 plus x is set equal to 360. So then when we have this equation set up, we can go ahead and add up our 135s as well as our 45, and we get 315 plus x is equal to 360. So what we did there was combine our like terms, or we could say we combined our constants. Now here we're going to solve for x. So this is just a one-step equation. We're going to subtract 315 from both sides of our equation. That gives us a 0 on the left, leaving us with just an x. And then when we take 360 and we subtract 315, we also get 45. So we've had two sets of 135 degrees, two sets of 45 degree angles. So here x is 45. You can also label it with that degree sign. Either way is all right, since here we have x degrees and we're just solving for x. Our next slide also has the same directions. Find the value of x. Here again there is the sum of 360 degrees. So here we only have one numerical angle labeled 35 degrees, but these two markings give us that each one of those degree measures is 90. So we actually have 35 plus 90 degrees plus another 90 degrees, then plus adding our x degrees, and set that equal to 360. Again, we're going to add up our 290 degrees, which gives us 180, and then we add that 35 to it, and we get 215 plus x is set equal to 360. Again, we just combined our like terms on that, and now we want to take 215 and subtract it from both sides. And when we take 360 and we subtract 215 from that, we're left with x to equal 145 degrees. Now our next slides are going to be talking about scale and scale factor. Here says find the missing dimension, use the scale factor 1 to 20. So this is called a scale factor because there are no labels. Scale factors don't need labels because their units are the exact same. So here we have inches and inches. So we don't have to worry about doing any sort of conversion. We're just going to set up our scale factor 1 to 20 and put it in fraction form. And then we're going to set up our second proportion, or set up our second fraction to create a proportion. So here we always want to do model over actual. So here our model is unknown, so we put an x in our numerator, and then our actual is 90 degrees, so we're going to put 90 in our denominator. For this, I'm going to use cross products. 1 times 90 gives us 90. Bring down our equal sign. X times 20 gives us 20x. And I'm going to bring that up here so we have a little bit more room So we have 20x is equal to 90. Here we want to solve for x. So we have to divide both sides by 20. So on the left side, we can cancel out our 20s. And x is equal to 4 5/10. And that would be 4 5/10 inches, since our label is inches. Remember when you're setting up your proportions that our numerator is always going to be the model, denominator is always going to be actual. There are a few other ways to write correct proportions, but it's the easiest way to remember that it's comparing model to actual each time. So our next slide has the same scale factor of 1 to 20, except our difference here is we're talking about feet to feet, not inches to inches. So we're going to set up our scale factor 1 over 20, and we're going to set that equal to the model, which is 3.75 feet over x feet, because we don't know our actual measure of degrees. So here we're going to do our cross products. We have 1 multiplied by x, which just gives us x, and then we need to multiply 3.75 by 20. And when we do that, we should get 7,500, but remember we have those two numbers behind our decimal. So we need to move it over once, twice. And when we do that, we get our x to equal 75, and our label is feet. So x is 75 feet. Our next slide says a scale drawing of a soccer field shows the field to be 6 inches long. The actual soccer field is 300 feet long. So there aren't any questions here yet. We're just given some information. Part A says, what is the scale of the drawing? So we need to be careful. Remember, scale has different units. So I'm going to go ahead and say the drawing, we're going to do the scale drawing first, is 6 inches. And we're going to put that in the numerator. Our denominator is going to be the actual length, which is 300 feet. Because this is scale and our units are different, we need to make sure we keep our units on there. But again, since this is a fraction, we're going to simplify. And I know I can divide both of these by 3. So 6 divided by 3 gives us 2 inches. 300 divided by 3 gives us 10 feet. Again, I can actually divide these by 2. So you could have started this off with just dividing by 6. But I saw 3 first, so I just decided to do that division. So I have 1 inch over 50 feet. And that would be our scale for this problem. Part B says, what is the scale factor of the drawing? Now, scale factor, there are no units, so we need the same unit, so we don't have to include our units on our final answer. So I have 1 inch is 50 feet, and that's our scale. So I'm going to go ahead and take our feet and turn that into inches. It's much easier to do it that way than turning inches into feet. So every foot has 12 inches. So I'm going to take 50 and multiply it by 12. I'm just going to use my 5 here and add a 0 at the end. So we should get 600 inches. So actually, I have 1 inch is over 600 inches, which again, since this is a scale factor, I don't need those labels, so I can just have 1 over 600. And that would be my final answer there. So when you're not given any units, it is assumed that they are the same units, so that makes it the scale factor. Scale has to include those units. And that ends our slideshow. Make sure you go back and watch anything you need to rewatch. Make sure you're also studying your notes. Your graded homework is a great resource to use. Happy studying!